Okay, so now we'll work number 17. So you've just got a lot of distributing to do, and you need to be careful. This is a -2 that needs to be distributed through. So the 98 stays the same, and then you have 48R plus 72, and then minus 18R and minus 4, because you have a -2 times both of those things. So both those things turn out to be negative. Then I would combine like terms. I'd leave the 98 alone. I would put 48 and minus 18R together, so that gives you 30R, and I would put 72 minus 4 together, and you get plus 68. Notice here I did not change this to a plus 4 and add 4 there and there. That's because the 72 and the -4 are on the same side of the equal sign. I'm not moving this -4 over to the other side. So that's a very common mistake. If the 72 and the -4, or the 48 and the -18, they're on the same side, so when you put them together, you don't change the signs of anything. You leave them the way they are. Now, I need to move this 68 over, so I am going to subtract it from both sides. So that'll leave 0, and I get 30 is equal to 30R. Divide both sides by 30, and you get R is equal to 1. So that's how you do that when you just have more to distribute. You combine like terms. So number 19 starts with ones where we have variables on both sides. So I tell my students it's like having socks and underwear in one drawer and socks and underwear in another drawer, and you want to organize. You want to get all of your socks on one side and all of your underwear on the other side. You want to organize things. So you want to get all of your variables over on one side. So you're going to subtract 5V from both sides. You could subtract 8V. It doesn't matter, just like it wouldn't matter which drawer you put your socks in, it doesn't matter which side you put your variables on. Most people like to have them on the left-hand side. You can organize it so that you always end up with a positive number. It really doesn't matter. Okay, so the 5V is gone. 8V minus 5V is 3V. Bring down your plus 8, bring down your equals, and then this minus 7 becomes a -7. Don't forget to bring your minus down as a negative number. And now we want to get the V alone, so I'm going to subtract 8 from both sides. So that cancels, so I'm left with 3V, and I have a -15 here. So then divide both sides by 3, and my answer is V equals -5. So just start by organizing, getting all your letters on one side, all your numbers on the other. It's very important to keep track of your equal sign and keep track of what side you're on. So bring everything straight down, okay? So that's those two. 23 and 24 have a little different situation, okay? So if you were to start working it, you would just distribute the -9. So you'd have -4 minus 9K plus 54 equals 50 minus 9K. So at this point, you could put your -4 and your 54 together. So you'd have -9K plus 50 is equal to 50 minus 9K. So then you can start organizing your letters. So you say, well, I want to move this over, so I'm going to add 9K to both sides. And then I get 0 for both of those. Like my letters completely cancel out, and I'm left with 50 equals 50. So when you get something like that, the answer is all real numbers. That means any number that you put in for K would work. I could plug a 2 in there or a -17. It doesn't matter. It's going to cancel out, and I'm going to be left with 50 equals 50, which is always true. So if you end up with something that's always true, your answer is all real numbers. We also call that an identity. Like this equation is called an identity because it's always true. Okay, something similar is when you have this situation. So you start, I would start by combining like terms. I've got a 10x and a minus 9x on one side. So that's 1x equals x plus 7. So now I'm going to get my letters. I want to organize my letters on one side. So I'm going to subtract x from both sides. But that gives me 0 equals 7. Well, 0 equals... Okay, I want to just finish that. My iPad cut me off, but I was just about done. When you get 0 equals 7, that can never happen. It can never be true. There's no variables left, so there's nothing to play with. There's nothing to make it true. So when you get something that cannot happen, you say no solution. So just watch for that. When all of your letters cancel out and you get something that's always true, it's all real numbers, meaning that you could plug any number you wanted to in for the variable and it would work. It would be true. No solution happens when all your letters cancel out and you get something that can never be true, and therefore you say no solution. Okay? Hopefully that makes sense to you all.